What's up, guys? Today I'll be teaching Science Form 1, Chapter 1. Okay, we'll just get right into it. So, I'll start off with everything here. So, today we'll be learning about Chapter 1, Form 1. There are 7 subtopics inside them. There are a few important subtopics that we are about to see today. One of them would be 1.3, 1.4, 1.5. These will be the 3 most important topics. Usually question revolves around this topic. In your first 3 months exam, they usually ask more detail. They'll ask topics and questions regarding 1.6 as well. But as you study more and come across more topics, 1.6 wouldn't be asked that much. So now we'll be moving on to the context, to the actual context of chapter 1. Okay, guys, so introduction to scientific investigation. We'll start off with what is science. Science is a discipline that involves a systematic observation and experiment of natural phenomena. Science is basically questioning what happens around you. For example, the formation of lightning, as you can see here, or the formation of rainbow, or the rise of the sun in the morning. Another example of science would be why does human have shadow, this dark figure behind us. That would be part of science. Why do we have such shadows? Whatever stuff that we don't know and we question about them, it is science itself. It can be related biologically, technologically, or chemistry wise. Anything is related to science. So the importance of science, as you know, science is very important. It contributes to many factors. It allows us to build many skyscraping buildings, communication, yield more vegetable, more crops, make more chicken, and then create vaccine to cure diseases like currently the COVID-19. They're creating many more vaccines. They are researching to create vaccines in order to fight against that disease. So now I'll be talking about fields in science. As you can see, we have 6 fields in science. Physics. Physics is the study of energy or influence of matter. Whatever we can't see is physics. Whatever that holds the answer to this universe is related to physics. Next would be biology. Biology is whatever that happens within us as humans, plants, even bacteria is also known as biology. We study the structure. For example, for plants, we study about the flower, the leaf, and how the roots grow in the bottom. And for humans, we study what's in our hand, and then we study what's in our eye, all of that. Then for bacteria, you study about the function of bacteria, what's inside the bacteria, how they move, and everything. Then next will be chemistry. Chemistry is you study about molecular structures. How does it form components? How do they interact? Like H2O, which is equivalent to water. All of this you'll be studying in chemistry. Next will be geology. Geology, basically you study about rock, soil, whatever's in the planet Earth itself. Here you go. As you can see, that's Earth, and whatever in the middle, like the lava equator or the heavy metal, all of this you study in geology. Next would be astronomy. Astronomy is whatever that happens in the universe, not above Earth itself, whatever that happens outside planet Earth. The moon, the sun, the Saturn, the asteroids, the comet, all of that. Next would be meteorology. You study about the weather, the rain, and then formation of lightning. Then sometimes you also study about snow, and all of this. Okay, so next we will go on to careers in science. So many careers can be from science. Even whatever are not really needed based on science is also revolves around science. For example, accounting and financing, there might be very very little requirement of science, but science still do exist. So science is a very very important subject. It makes us think logically in order to act relevantly and rationally, therefore coming up with better results. As you can see here, these are the carriers of science, and these are all the subjects that these science people major at. Like for example, to become an astronomer you need to be good at physics. Vice versa, to become a doctor you need to be good as a medical doctor. To become a pharmacist you need to be good at pharmacy. And to become a geology you need to be good as a geologist. As you can see here, there's one thing that all of them do share in common, which is teacher, 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 and teacher. So all of these people have teacher. So whatever, as long as a teacher has basis in science, they can actually become anything, but instead they choose to pursue their passions to teachers instead. So as a teacher you will have to know almost all of this subject. Okay, so next would be innovation in technology. I don't think I need to say much about this. As you can see, last time we started with a huge brick like structure, stone, and then now we can even communicate from the watch. At the current moment we have technology where it can work on the ring itself. So like for example, if you have a ring, it has Bluetooth, Wi-Fi, everything in it, so you can just check your Twitter status and you can check your WhatsApps and make calls from there itself. Okay, so this is all done for 1.1. Now we'll be moving into 1.2, which is your scientific laboratory apparatus. Okay, before I begin about explaining about the apparatus and all their function, I would like to talk about the difference between material and apparatus. So apparatus versus material. So I do have to say that apparatus is something that can be used many times, whereas material can only be used once. Once it's used, it has to be disposed. On the other hand, apparatus can be washed and reused again and again for other experiments. So common example of material would be tissue paper. Tissue paper is a very common material that you use during your scientific experiment. Or maybe toothpick, because you can't reuse toothpick for the other experiment, you usually throw it away. So as long as you know the difference between this and this, you wouldn't get confused as you progress in your education, because this is something that not many students know, and if they know this, it makes their life very easy. Okay, so now I'll be going into laboratory apparatus. There's nothing much to say. The functions is just right there, it's stated there, and it's very common. So the difference between boiling tube and test tube is that boiling tube can be held over the fire for a longer period of time, and it can withstand heat more compared to test tube. Next would be beaker, conical flask, and flat bottom flask. All of them can hold chemicals or water or anything inside them. Just the difference is the amount of water it can hold. Beaker can hold more compared to conical and bottom flask, but that usually depends, because we have beakers ranging from 50 ml all the way to 500 ml. So it really depends. Next would be measuring cylinder. This one is to measure the volume of liquid. Then you have burette and pipette. Okay, so these two has a very big difference. Burette, you get to measure liquid more accurately compared to measuring cylinder. That's one thing you have to keep in mind. Another thing is the style of reading you have to take from burette is like this. Okay, usually the number will be starting from 0.00 and then all the way down here to about 100. Okay, so if you see there, it will start off at 0 0 all the way to 100. So you have to take wherever the liquid stops, you have to take this part and minus it with the final volume. So let's say, for example, the liquid stops at 50 ml. You have to take the 50 minus it with the 100, so that means the amount of liquid that came out is 50 ml. Okay, pipette on the other hand, you'll measure a fixed amount of volume in a liquid, but very accurately. Okay, so when you fill up water inside a pipette, the water will fill up all the way from the bottom all the way to the top. It will fill up this big gap, and you have to pour the water accordingly until the water's meniscus hits this line here. I think you guys can see the line. You see this line? You see this line? Yeah, the water has to hit that line. The moment it hits the line, the measurement that has been stated on this pipette, usually it's about 25 ml. The measurement that's stated on the pipette would be accurate. If the water exceeds more than the line, the volume immediately will become unknown, because there's no other measurement on it besides that one line. That one line indicates the amount of volume that will be held in the pipette below it. Okay, next will be tripod stand. Tripod stand is used to put stuff above it for heating. Wire gauze is kept on top of the tripod stand to ensure even heating of the substance, so the heat will spread evenly around the wire gauze. It wouldn't just hit in one direction only. Like for example, if you put the fire down here, the Bunsen burner, instead of just hitting it up here only, if you place a wire gauze on top of it, it will spread evenly to every area. Okay, next is filter funnel. It will help to separate insoluble solids from mixtures. So like for example, if you have water, you have a lot of water here, and the water contains a lot of pebbles, very fine pebbles and sand, and if you place it in a filter funnel with a filter paper, you have to place a filter paper as well. If you place it with the filter paper, the liquid will be the only one that will drop out, whereas the fine pebbles would stay up. So next is gas jar, that's to contain gas inside them, followed by retort stand with clamp. Retort stand with clamp is usually used to hold very long apparatus, usually such as burette. You place the burette here. When you place the burette here, it'll be suspended in the air, like it'll be hanging. It'll be hanging like this. Then you will place a beaker in the bottom to carry out the experiment as you record the water dropping. Next will be evaporating dish, is to make sure the liquid inside here evaporates to the surrounding. Okay, next we'll be talking about symbols and hazard materials in the laboratory. There are about 6 symbols. Irritant are fumes or vapor that once they enter your eyes or nose, it will hurt. You have to avoid inhaling this vapor. Example would be chloroform and ammonia. So next would be radioactive materials. They emit radioactive rays. These rays can cause cancer. They could damage your cell's DNA very badly. So example of them is uranium and plutonium, followed by corrosive. This substance, the moment it touches your skin, it will melt your skin away. So example is concentrated acid and alkali. Then when you see this type of symbol, it usually indicates poisons. You shouldn't be touching them, eating them, or smelling them at all. You should stay far away from them. One of the most dangerous chemical is mercury. A very slight dose in your body would be enough to kill you for good. Like, there's no chance of survival. That's how bad it is. Usually they exist in thermometer, followed by explosive. This chemical is, once they get in contact with fire, they'll just explode. Example is hydrogen gas and butane gas. Some, like hydrogen gas, for example, this particular gas doesn't actually need fire to expose. The moment it's released into the air, it will react with the oxygen in the air and cause an explosion. And then followed by flammable. This stuff will catch on fire very quickly, and they won't explode, but they'll burn. They'll cause fire to occur. Next is rules and safety measures in laboratory. There's nothing much to explain here. As long as you don't do anything dumb or stupid, you're good to go in your laboratory. Just like behave, listen to whatever the teacher says. Don't enter the laboratory without the teacher. Don't eat anything in the laboratory. Whatever that's fun, you're not supposed to do it in the laboratory. That's all. Okay, so that will be done for 1.2.